This video will show how Desmos is used for linear regression. We'll start by putting a list on the program and then calculate the linear regression line and see what else shows up. So we're going to first start by inserting a table. So we're going to hit the plus sign and pick table. And for X, we're going to put in our protein. So we have 7. Three, 26, 30, 17, and 6. Okay, and then we'll go back and put our Y in. We have 9 and 10. Notice how the graph is taking them and going ahead and plotting them as we go. So as soon as, I'm just going to make this a little bit bigger for us. Try to shrink this down, not too much. Sorry if that made you sick. I'm not the best at that. So to get that linear regression line, we're going to type Y1, and we're going to have this little squiggly line, and you'll get it by going to, notice I click this ABC, and it's right here, squiggly line, M for slope, X1 plus B, and I get that regression line. It tells me what my slope is, that it's a positive 1.1296 or 0.13, and a y-intercept of negative 1.39. So that is telling me definitely when the, for each gram of protein, when protein is 0, we expect our fat grams to be negative. Don't we all wish? But, so it doesn't really make sense, but it is the definition. It is the interpretation. I talked about that more on the TI-84 video that we did. One nice thing is the statistics automatically comes up here, and it shows your R value of 0.979. And we can see that those are really close to the line, and 0.98 is really close to 1. So this would be a strong positive linear, and that R value confirms that for us. Now, one of the things that we will talk about is residual plot. And the residual plot, if we look at the residual means, residuals are the distance from the dot to the linear regression line. So the distance from this line to that is the regression or the residual for that value. So we find the residual by taking the actual Y value minus a predicted Y value based on the linear regression line. And when we graph the residuals where the x-axis becomes the linear regression line and the dots are on above and below, if we see no pattern, okay, we kind of see scatter here. No pattern, scatter means linear is a good fit. If we saw some type of pattern like a U shape or an exponential shape or something like that, we would know that a linear regression would not be the best fit, and we would try something else like a logarithm, natural log, square root, any of those types of regression. So there's lots of different types of regression, not just linear. But this residual graph shows definitely that we have that, and it's all right here on the graph. I really like we can turn off the residual by just clicking on that dot, or turn off those and turn on the residual, back and forth. So I hope this helps with your bivariate data in Desmos. Very easy to use, and I think very beneficial for you and the students.